Sorry for those that are watching the video now, I missed a little bit, but we just started really. And then cubics are the third type of equation we're going to be looking at. They have a cube up top, that's why it's called cubic. And we'll see our power 3. And once again, it might have a constant in front. So what I want to talk about here is the two different ways that these can look each time. For linear functions, they can do two things. They can look like this, or they can look like this. The top one is if we have a positive number in front of x. The bottom one is if we have a negative number in front of x. Okay, it either looks like this or like this. For quadratics, they either look like this or they look like this. The top one is if we have a positive number in front of the x. The bottom one is if we have a negative number in front of the x. What I like to think about is if you have a positive number in front of the quadratic, that's a good thing. It makes a smiley face shape. So I kind of imagine it being one big smiley face. Plus means positive. Positive is good. You know, all those things make the smiley face in front of all these things in front of you. All these things relate to a positive number in front of the x. It makes a smiley face. You can probably imagine that the other way, it's kind of a sad face. So it makes a sad curve. Negative is bad, unhappy, that kind of thing. It's just a way to remember it. And finally, cubic either looks like this, whoop, or whoop, like this. Okay? This is if we have a positive a, and this is if we have a negative a. How you remember that is you go up, then down, then up. 3 ways. Up, down, up. 1, 2, 3. Cubic. Up, down, up. 1, 2, 3. The other way would be down, up, down. If there's no other numbers, though, it just kind of goes flat. Up, over, up. The reason I'm telling you this is because you can do a lot of sketching graphs. Smiley face, sad face. You can sketch a lot of graphs very easily if you just know these basics. So let me do that right here. For example, this first question.
It's linear.
It is linear, exactly. And we can say that the number in front is negative. Sorry, I'm trying to erase this. My computer sometimes fights me. Yeah, this is negative a. So a is negative. So it should look like that, right? Don't draw that yet, but it should look like that. I'm going to put it on Desmos because I'm just asking for a simple sketch. I don't even really care if it's to scale. So you should bring up Desmos and let's put this function into it, okay? If you only have it on your phone, do that. If you don't have it on your phone or anything, you know, just watch for now. But I want you to at least give it a shot at some point. So this is -2 divided by 3 x plus 5. So this function looks like this. And if I look at this function, let me get some special points. This one looks special here. Oops, sorry. That's special, and that's special. So I can sketch this now. I'm going to put at 0, 5, 1, 2, 3, 4, 1, 2, 3, 4. I'm going to put a point here. And at 1, 2, 3, 4, 5, 6, 7.5, I'm going to put a point there, and I'm just going to connect them. And you should probably use a ruler for that. In fact, you should use a ruler, and I'm going to use a ruler as well. I've got all the points I need, so I can get rid of Desmos. You should have a ruler, and you should draw your line. Okay? And it is just a sketch. I'm not looking for perfection, but I am looking for a couple important points. So this, remember, was 0, 5. This was 7.5. And that's all you need to do to sketch it. You are allowed to use a calculator on your phone because, first of all of you can get it. It's on Android, it's on Apple. You can go to it as a website. There's no reason you can't go get that. And why not? I mean, you're all at home. You're going to use whatever you can anyway to get you through. So use Desmos and sketch the graph that way, okay? So we know it was negative. It looks the way we want it to. Desmos confirmed it. We took a couple nice points out of it. End of story. Okay? Are there any questions on this graph before I try a different one? Abdullah says no. I'll go with Abdullah. Let's try this one. Right away, I'm looking in front of the x. First of all, I see that it's an x, and it doesn't have a power, so that means it's linear. And second of all, this number in front, a is positive, which means it should look like. So I'm going to go right away and sketch it on. If you know how to sketch this by hand, go ahead and do it. It's fine. You can do it whichever way you like. I'm going to put in a new function here. This function is 1 divided by 4, x minus 3. And it looks like this. Now, which points are important here? Where it crosses axes usually is what I care about. Sorry, I was jumping around. So right there and right there. Those are two important points. Let me sketch it. Let me look at my graph. I want to go 12 to the right. I can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't even got 12. So let's go in groups of 2. 2, 4, 6, 8, 10, 12. I'll put a point right here. That'll be 12, 0. And then we're going to go down 3. 1, 2, 3, and put a point there. That'll be 0 and negative 3 is that point. And once again, I'm going to connect those two. Now, just by seeing your assignments, I know that many of you were able to print these. So that's why I don't mind making you do this. If you don't have a printer, you need to get graph paper. It's just a requirement, all right? Get yourself something to sketch on. They don't need to be perfect sketches, but I do expect you to be able to sketch if I ask you to, okay? And this would be enough to sketch this. You can, of course, sketch these using a table of values if you want to. What I mean by that is, you know, you could set up x and y and just try a couple points like 0, 1, 2, put all those numbers in to this guy. So 3. Putting in 1, we get 1 over 4 minus 3. Putting in 1, we get negative 2.75. And putting in 2, we get negative 2.5. But you'll see that if you do a table of values, you kind of have to know ahead of time what the nicest values are. And that's not always so easy. So some of you might think, why are you making me use Desmos? Why can't I just do it by hand? Well, I think the opposite. Why would you not want to use Desmos? It does it for you, and you just take the special points out of it. All right? So let's see here. First of all, are there any questions on that? I want to move to one more type of question.
That means no need for the table, right?
No need
in the
for
exam
table.
or assignment. Okay.
No, if you keep good track of the points, if you've labeled the points, you've basically made a sketch of what you see on Desmos, that is enough for me.
Okay.
So this question, you'll notice I put some red here. That's because technically in this course, I read the outline. You shouldn't need to be able to do anything past your basic squares and cubes, not for this topic. So I'd like you to try and sketch this. I want you to sketch, I'll just cross this out so it's obvious. I want you to sketch this function. You can even, with the annotation tools, you can even draw on my grid if you like. I want someone to draw what they think this sketch is, okay? You can put it on Desmos and check it out. You can make a table of values if you want, but I want you to come up with a sketch of this function. It should take you about 1 minute at most. I'll give you a hint. Again, you can use
quadratic.
Yeah, quadratic.
It's in the middle.
It's in the middle from 0.
From 0.
How can I say
The
Right.
origin, yeah, the vertex is at 0, is what you would say.
Yeah, it's in the middle.
Yes, yes.
0 and till كيف نقول له؟
This one's a tough one because
It's
even
a
if you
small
graph
u.
on Desmos, what's that, sorry? I'll graph it on Desmos so everyone would see, and I'll confirm that this x squared is what I expect it to be. X squared. It looks like this. The problem is, you know, in order
Yes,
to
yes.
make a nice sketch, you need to at least have a point, because there's no special points here, really. You know, is it this big? Is it this big? Is it this big? How big is it? So for quadratics, you should check 2 very quick points. So I know you didn't have to make a table of values. I kind of lied a little bit, but this is a slightly different type of question. This is a
The
linear.
value before the x, it means how much it will be open or close to each other.
Yeah, how stretched it is, really. But the easiest way to do this is for x, make x negative a and see what the value of y you get is. Go left by a, sorry, just go left by 1. Okay. Let me show you something.
Negative it means it will be, there is a maximum top, I think.
Sorry, what?
If it's negative, it means it's maximum, it's not minimum. Like, it's like
Yes,
n.
yes, yes, yeah. So I'm checking, I'm going to put 1 in, and why I do this, and it's just the rule for these. You'll go over by 1, see where we get. Well, it goes to 2, so that's 1 and 2. This is that blue point here, okay? And then I'm going to take -1 and see what it gives me. If I put -1 into this, it's 2 times -1 squared. That also gives me 2. So I get this point here. So it's kind of stretched. What I mean by stretched is it's not very wide. It's very thin and tall. And I'm going to sketch that. I'll just sketch it like this, and that's enough. It doesn't need to be perfect. But you need to be able to show at least a few things, okay? Let me show you a comparison. This is x squared. What if I graph 2x squared? You see the difference? The green one is the original, and the purple one is the 2x squared. It's kind of like it got stretched up. So for those of you, I'll just say one more thing. If I had some ax squared, look at this. This is why I like Desmos so much. If I make the a bigger, it gets stretched out. It's like you're pulling a rubber band, pull, 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 pull. And if I make it smaller, I squish it, I compress it down. And it gets wider, 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 okay? So the bigger the a is, the more stretched it is. Oops, sorry about that. Stretch, stretch, stretch. The smaller it is, the wider it goes until it goes negative. Okay. So anyway, Desmos lets you do a lot of crazy things, but let's keep it simple, all right? Let's recap. It's a quadratic function because we see a square. The number in front of it is positive, so it must be a smiley face shape going up. And then when you got that done, just check -1 and 1 and see what the numbers are. You'll have your shape. That's it. That's the whole process. So I want you to try D, and then we're actually going to move on. Because the rest of the examples are pretty much the same. So talk me through this. Is it a linear, quadratic, or cubic?
Quadratic.
Quadratic.
Quadratic, you got it. It's a quadratic.
Okay.
And the number in front of it.
Downward.
So in this case, we have a is negative. So we should have this downward opening. Opens down, sad face, I don't care
Sad
what you
face.
call it, but down. And the origin's at 0. Because if we put 0 in for x, we get back 0. We don't have any other 2 points. So what do we do? What do we normally do with quadratics? I just did it. I check -1 and I check 1. So f when x is -1 gives -1 squared. That is -1. And then f when x is 1 gives -1 squared. That is still -1. Because you'll notice it's 1 squared, which is 1, and the negative's outside. So still -1. And I'll just put those on my graph. There we go, and it looks like this. Okay, something like that. Again, my sketches aren't perfect and yours don't need to be either, but you need to be able to at least do the basics. And these are the basics. Clear?
Clear, yes.
Yes.
Clear.
Okay. Cubics work the exact same way. I'll do one very quickly, just so that we have it done. This next cubic example, I've canceled the rest, you can see. I'm going to make it more clear. I'm only looking for 3x cubed. First of all, it's a 3, so it's a cubic. Second, there's a positive number in front. A is positive. That means it's a positive cubic. It goes up and then up again, or up, down, up, and then down and up. It should look like that. So it should look something like, well, not like that. It should look something like this. That's my guess. It's not really a guess. I know it needs to look like that. Let me try it in Desmos, which is what you should do too. Again, it has a really nice app. It looks exactly the same on the app as the website, which is a really good bonus. Let's see, 3 x cubed. Where's my cubed? I need to look for a power. It's probably hidden back here. Wait, a to the power of anything, a to the power of b. Okay, 3. Whoa, that's ugly. I'll just rescale it. Let me see here. Back to normal. Zoom in a little bit, and it looks exactly like I want it to. I thought it needed to go over like this, and it does. Now, which points am I going to take? I'm going to take 1 to the right and 1 to the left. 1, so I'll just annotate this so you can see. -1, it should give me this number. It should give me the number -3. And 1 should give me the number 3. So let me actually check that and see if it does. It's always nice to be able to do it by hand. So the function, when x is -1, gives me 3 times -1 cubed. That's the same as 3 times -1, which is -3. That's exactly what I thought it was going to be. That's exactly what Desmos told me it had to be. F, when x is 1, is 3 times 1 to the power of 3. That's 3 times 1, which is just 3, which once again is exactly what Desmos told me it was. The values I'm getting out of this are -1 and -3 and 1 and 3. So hopefully I'm not doing that too fast. I'm trying to do it as fast as I can without losing you. And if you do get confused, just watch this little section of the video again. But let's sketch it. I've got 0, 0, -1, -3, and 1 and 3. So 0, 0, -1, -3. Do I want to scale it? Do I just want to go over by 1? It's kind of, I don't know. I'm going to go over 1, 2, 3, 4, 5. I'm just going to say this is 1. 1, 2, 3, 4, 5. Just because I don't want it, this tiny little graph that looks like this baby little thing. I'm just trying to stretch it out. You can scale it whatever way you like. And let's see. I'll call this 3. 1, 2, 3, 4, 5, 6. I'm going to go up by 6. 1, 2, 3, 4, 5, 6. I'm just trying to scale it so that I've got a big enough graph, but it's up to you how you scale this thing. That would be like this and like this, and just connect the dots. Up, over, up. And you can keep going. There's no reason why you can't keep going past. You just extend the function. Of course, it goes on forever. And that's our function. I don't expect you to be perfect at this. If you wanted to sketch it differently, but still put the points in at the right place, that's perfectly enough for me, okay? And we can see here that's the same as what I put on the Desmos side. So that's how you sketch basic cubics, basic quadratics, and basic linear functions. Can I clarify anything before we just move on to the next topic here?
Yes,
Yep.
clear.
Clear?
Clear. Yes.
Who's the mystery dot person? One of you in the chat is just a single dot. Who is that? Do you know you're a dot?
Not me.
Actually, no. I'll.
It's you. You're a dot.
Yes,
Who are you?
Ahmed.
Okay. Okay. You can change your name, by the way. You don't need to now. I'm just saying. It's just funny. Okay.
How can I change my name?
So I think in your settings, I can actually, I can go in and call you whatever you like. What do you want to be called? It's a dangerous question. You say Ahmed?
Yeah, Ahmed. Ahmed Hussein.
Ahmed Hussein. Yeah?
Yes, thank you.
I got your back, man. Okay. So let's move on then. The next thing we need to do is verify ordered pairs, which just means check values on a graph, see if we have what we want to have. So let me show you. If you watch the videos, which again, you always should, if you don't, you're missing half the content. You should already know what's going on here. So it says, at times you may be asked to verify that a given graph represents the actual function we're talking about. So you need to get an ordered pair from the graph and then check if it satisfies. In fact, we need to get 3 ordered pairs. Because if we don't get 3 ordered pairs, we can't be sure that we're actually looking at the function that we think we are. And we want to look for ordered pairs. Ordered pairs is just coordinates, by the way. Seek ordered pairs that fall directly on the intersection of the grid lines. So let's get to the point. Let me show you what I'm talking about here. Mr. Tom already did example 9. Okay, so that's in a video already. In the practice here, it says we need to verify that each graph is represented by the given function. Okay, verify the graph below is of this function. So it's saying, first of all, does this graph, is this equation the equation for this graph? Or if I was to stick that into Desmos, am I going to get back this graph? Yes or no? Well, it looks like it's on the right track. I can see that there's a quadratic there, so it should definitely be this shape. And the number in front of it is positive, so it should definitely be the smiley face shape, but I don't know about the numbers themselves. So I want you to tell me there are 5 points on this graph that I think would be really good to check. What I mean by that is, for example, this point here is exactly on an intersection.
0 and -1.
0 and -1 is also 0 and -1, yeah, is a perfectly good one. So I'm going to label them. So that would be a good one, -2 and 5. I couldn't hear if
6
anyone.
and 5.
6 and 5, exactly, yep. And I got one more. I'm looking at this one. I'm going to write them down. You don't need to write
4
every
and
single
-1. Yeah.
2 and -3, 4 and -1, and up here we have 6 and 5. Okay, so that's the first thing you should do. You should take a look at the function and find all the nice values, all the places that are obvious. It doesn't matter which ones you choose. You could actually choose any, but we don't want to guess. We want to find nice numbers. So we found 5 sets of nice numbers now. We need to check any 3 of them. So what one would be easy to check? Well, first of all, 0 and 1 would be really easy because x is 0. So that's one that I'm going to check. I'm going to check f when x is 0. I don't know ahead of time. I actually didn't do this example yet. I didn't check ahead of time if all the points work, so I'm going to be as surprised as you are. Why did I choose 0 first? It's because 0 deletes things. So it should be a little easier. Let's see. F, a function, when x is 0. So that's a half, 0, minus 2 squared, minus 3. So again, all of my x's, all I do is replace them with 0. That is 1 over 2. Out of those brackets, that's negative 3 cubed. I'm not going to show all the work, actually. I'm just, yeah, okay, I will. Sometimes I feel bad. That's negative 2 cubed minus 3. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. So some students are like, why is it negative? That's why it's negative. Negative 8 divided by 2 is negative 4.
Sir, it's not power 3, it's power 2.
Mm-hmm. Good call. Good call. You're right. It's a 2. That makes this way easier. Thank you. So that's a half. That's a half of 4, which is 2. 2 minus 3, which is negative 1. Okay. So this confirms something. We know that the point. Let me try to make this more clear. I'm just going to move things around just a little bit. I know some of you don't like it when I do this, but it'll be better for you later. Why is my computer fighting me today? Technology. 1 second. There we go. I'm going to squish this down because I want to show you exactly what I'm taking off the graph. So from the graph, I'm checking the point 0 and negative 1. The 0 is the one I care about here, which I'm putting in to the function. I got back negative 1. That's an excellent thing. That means that I actually got what I'm looking for. Now, which should be the next point that I check? And there's no right answer. I've got 4 other points. I just check whichever one I want.
2 and negative 3.
Sure. That's a small x value. It's the next one. It's no negatives. Seems like a logical choice to me. So I'm going to put in 2 and see what I get. That's 1/2 2 minus 2 squared. That's a really nice one. It'll cancel entirely. Minus 3. So that will all cancel. You can try it yourself on the calculator. It comes out to 0. And that's negative 3. So right away, 2 and negative 3, when I put in 2, I get negative 3. That is confirmed. That does work. So far, I've got this point checked on the graph, and I've got this point confirmed. Any other value, if I check it and it comes out correct, I know that this is the right function, okay? So let's go ahead and do that. I'm just going to go for number 4. Why not? 4, negative 1. So when I put in 4, I should get negative 1 back. You should check this yourself, right? I don't want to bore you to death. Just check it on your own page and see if you're getting what I'm getting. If I put in 4, what do I get? 1 over 2. 4 minus 2. Square it, take away 3. 4 minus 2 is 2. Square it, I get 4. Divided by 2, I get 2. 2 minus 3 is negative 1. And that 4 gives a negative 1. Yes, it does. So it's good. I'll just give a final answer. Yes. The graph is the function f of x. I'm not going to write out the entire equation again. It would kind of be a waste of time. But I can say the graph is the function f of x. So I'll summarize the steps. Choose any 3 nice ordered pairs. If any do not match, it's not f of x. Okay, I'm sorry if you can't read my writing. Sometimes it's good, sometimes it's not. Depends on the day. I don't know if any of you are like that. I'm left-handed too, so some of you know that that sometimes makes a difference. But the idea is choose any 3 nice points, and then if they match, if they all match, we can be reasonably sure that it is the function. Anything you want me to go back over for this?
For me, no.
What about for Aisha, or Ahmed, or El Sadeg, Salah,
No.
Ibrahim, Juma, Mohammed Taha, Nora, Nurania, Sarah, Tarek, Yasmin? I have a lot of people
No.
here today. I'm becoming famous.
Yes.
They heard about me on YouTube. I don't know. Is that yes?
Yes.
Okay.
That's good.
Okay. Good. Show me. Try B. Choose any 3 nice points and tell me if the function is matching the equation. I'll give you 2 minutes,
1 and 2.
or maybe 1 minute.
3.
Sounds good so far?
Yes.
I mean, any one of you, if you want to, you can write on the screen. It doesn't bother me at all. But any of you right now, you can choose any 3 of those points. If a single one of those points does not fit, it's not a function. It's almost 2 minutes. -3 and 4. Sounds good. Yeah, it's not a function. So which point did you check, Mohammed? Just so I can check the same one and we'll see. So from the graph, and let's see if we can check it on the function.
Mr. Scott, it shouldn't be specific in for like -3 and 4 or -1 and 2. It shouldn't be when I put -1 in the equation, does it give me 2 exactly? It's fine.
No, that's exactly the point. Is that on this graph here, let's just check that, for example. On the graph, I'm looking at -1 and 2. That is what that says. The graph is telling me for sure that is exact, okay?
Mhm.
So the function, again, we're checking to see if the function is this equation or not. You know, if this graph matches the equation, it might not. So if it doesn't match, it's probably a good idea. It's probably a good indication that it is not the function. So I'll put -1 in and let's see. So that's -1 going to be squared, which will become 1. 1.35 times -1, and then plus 3.1. I'm just going to multiply that out and see what I get. I haven't done it yet. Tarek did a different number. He got, okay, you're getting 2.3. I'll just double check it on my side. Plus 1.34 times -1 plus 3.1. Yeah, 2.3. And so you were saying, you know, I'm not getting exactly 2, I'm getting 2.3. Is that okay? Well, actually, probably not, because this function, if I just zoom in here, 2.3 is, you know, this is 3. 2.3 is probably over here somewhere, really. And that clearly doesn't match what the function is telling us. So it's like trying to trick us, but we're not going to be tricked. I refuse to be tricked. That point doesn't work, so I'm going to just say this point is not a match. So I'm going to say this graph does not represent f of x. That's it. Now, some others, you probably checked different numbers, yeah? Did you check any of the other ones here? What about -3 and 4? Did that work? Or what about 1 and 4?
It seems not exactly.
So they're all off by a little bit?
Yep.
Okay, so -5 and 10. So would it be safe to say that all of these don't match exactly? Again, I didn't check them, but I'm pretty sure that's the case. I should probably have full workings for this. I'll post them again later. Speaking of which, did you notice that on content in D2L, I've put my handwritten solutions in there now?
Yeah, I see for last videos you put the notes.
So I put Tom's videos are up there now. My videos from the classes are up there now. And my handwritten notes, these notes are up there. The problem with this program, OneNote, is that when it prints, I have very little, I'll just show you. This is what I go through. I try to print these notes so that you can see them online, of course. But let me show you what happens. When I print them like this, it has very limited options. It prints like it cuts off half the page and all sorts of crazy stuff, okay? Apparently it's gonna take forever today, just because I want it to work. But anyway, sometimes it'll cut off half the page. I know that's, there you see it, right? I know that's not the best. Let me fit the page. That's not the best for reading it, but I really don't have a choice. I don't even have the option to change that. So hopefully it's better than nothing. And if I can figure out a way around it, I'll do that.
We can use computer or
Yeah, of course.
iPad or phone to see the notes. Okay.
In any case, I just want you to know it's there. So what it says on the bottom of this function here, and I'm going to move on. I'm not going to do question C. It says, care must be taken when choosing ordered pairs. As seen above, you cannot conclude a graph is correct by verifying only one point. You must test a number of points equal to the greatest exponent plus 1. That's just a fancy way of saying whatever is on that x, you need to add 1, which is why we're choosing 3 points. X squared, the 2 plus 1 is 3, but I'm only going to give you quadratics anyway, so don't worry about that. Basically, test as many points as you can. If any are wrong, it's not a function. This one I've just said is for homework, which it is. I'm going to set it for homework. Choose to do it or not do it, but you'll be responsible to understand it. Okay? Can I just get a show of virtual hands in the chat or on the participants list? Who is already familiar with domain and range? Because it'll drastically change how I approach this. Mohammed is familiar. Anyone else? You can give the thumbs up, thumbs down, all around. Aye. Anyone else? I thought I was going to get a thunderous response. A little. Okay. Domain and range causes a lot of trouble for students. So I'm going to try to explain it as clearly as I can. Mr. Tom has already explained it, but of course I'm going to try to explain it again just because it's such an important topic. And then you'll have 2 different explanations and you choose whichever one makes more sense to you. Of course, there is no one right way to do math. There are many ways. Domain and range. I just got a couple notes for myself. First of all, domain is related to x values. Range is related to y values. What it is, domain, in other words than what's written here, domain is all possible input values. What that means is, you might be given a function, for example, root x. If I put numbers into that function, am I allowed to put a 1 in? Yes, I am. Am I allowed to put a 5 in? Yes, I am. Am I allowed to put a 0 in? Of course I am. Am I allowed to put a negative number in? Well, if this was complex numbers, we're allowed. But for this unit, we're actually only looking at real numbers. So we say we're not actually allowed to use that x. which means the domain is 0, because that's okay, and every number bigger than 0. We're not allowed to use the negative numbers. So let me write this down. I'm actually going to erase it. But the domain, the way we write this, we say the domain is the set of x values. I'll write this again. The set of x values such that x must be greater than or equal to 0, comma, and x can only be real numbers, or it belongs to the real numbers. That's an R, by the way. So that's how we would write that. Now I'm getting ahead of myself, but I just wanted to show you the thought process. I'm going to erase this so it doesn't throw you off. The range is all possible output values. So whatever you put into this function, the range is all the possible values that can come out of the function. For example, if I have the function x squared, and if you were to graph this, it would look like this. Well, it looks to me, what are all the y values here? It looks like everything above 0. You know, if I'm looking at just y values, it looks like 0 is okay. You know, 1, 2, 3, 4, 5. All of these y values are perfectly fine, but there are no negative y values. So the range of this function would be everything above 0, nothing below 0, because there are no y values below 0. Okay, so again, I'm going to go through some examples on this so that I can make it crystal clear, but I always like to introduce the topic as clearly as I can. Now, believe it or not, and I struggle with this too, many students don't know which one relates to x and which one relates to y. Some students think domain is y and range is x, but that's not true. So let me try to make it as clear as I can. It's just a way to remember it. In the alphabet, D comes before R, correct? A, B, C, D, you're at D. That's before R. Also in the alphabet, X comes before Y. H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, X, Y, Z, okay? I shouldn't need to tell you the alphabet, but who knows? I don't know who I have in my class. I haven't even met you before. My point is, domain goes with X, range goes with Y's. If I ask what the domain is, I'm asking you what are all the possible X values. I ask you what the range is, what are all the possible Y values. So it's probably about time that I get to an example, but I'm almost done talking about this. So when you're determining the domain and range, there are two important things you need to look for. The first thing, and they're written here, values that lead to division by 0, which means if you see anywhere you're going to end up dividing by 0, that's a problem. We have to note it. I'll show you how to note that. The second case is if we have square roots of negative numbers. So again, in the first unit, that was okay. But in this unit, we're only looking at real values. So we're not allowed to have negative square roots. So nothing that looks like this, you know, nothing that has a negative inside the square root. Okay. And again, I'm just trying to front load this so we have everything we need. I'm almost done talking. I'll go through an example in a second. Some tips. How do you get the domain and range? 3 steps or 3 tips that I'll give you. First tip, graph it. Put it into your phone, look at the graph, and try to figure out what the domain and range is. Second, determine any problems with the X values. So for example, if there are certain X values that don't exist on the graph, or there's a big space or anything, you note that down, you have to put it in the domain. Finally, the third step, write the domain, then write the range. Let's get to this. Let's do some practice, okay, so that I don't lose you entirely. Practice 4, determine the domain and range for each function. So Mr. Tom did A, I'm gonna do B, and then I'm gonna have you do C and D. Before I do that, you'll notice here, you probably have seen these on my notes. These are QR codes. If you scan them with your phone, they'll bring up usually a Desmos graph that I've made for you so that you don't need to make it yourself. It just saves you a bit of time, okay? So if you're interested in that, take your phone, put on a QR scanner, and put it in, get the graph. But for now, I'm going to make it from scratch. So let's make a new graph. In this case, I want to do practice B. I need the domain and range, the x values and the y values. Square root, where's my square root here? Where's my square root? Square root of 3 minus x. Oops. 3 minus x. Delete that. Okay, so this is an interesting function, or at least I think so. This is what this function looks like. This is the function. Sometimes when I put this up, it freaks out. Y. Annotate, please. Y equals root 3 minus x. Now I'd like you to tell me, what are the possible x values? You know, I've graphed my function, I did step 1. Are there any x values that don't exist on this function? For example, if I choose x, that exists because it has an accompanying value here. If I choose -4, it clearly exists. Any of these all exist. I can find their numbers. 0, does that exist? From 3 to positive infinite. So the numbers that do not exist, yeah. Anything here, there are no x values. If there's no x values, it means that they don't exist in the domain because the domain is all possible inputs. So what I would write for this, and I'll actually just write it over to the side here. The domain is the set of all x values such that x must be less than or equal to 3, and x is part of the real numbers. There are ways to do that by hand, which I'll show you after I finish. But for now, let me talk about the range. The range is the set of all y values such that, what are all the possible y values that can come out of this? I'll tell you 2 ways to do this. First of all, let's look at this function. You know, this y value is okay. For example, you know, 2 is okay, 3 is okay, 4 is okay. Believe it or not, you know, you can, I could stretch this out, it would keep going. 0.5 is okay, even 0 is okay. But nothing below this function exists. What I mean is, there are no y values smaller than 0. Some of you might still be lost. Maybe you're not sure what I'm talking about. Let me try to make it clear one more way. This is our function. I can zoom out forever. It'll in fact go on forever. What I'm trying to say is, down here, there's nothing. But everything above that, we're allowed, you know, all of these. Y greater than or equal to 0 exists. It's okay. All the x values, all the x less than or equal to 0 exist, but a greater than 0 does not. And this is what it means by domain and what it means by range. It's a tricky concept. It's especially difficult to explain it online, but essentially just look where all your x's are, look where all your y's are, and it should be okay. So what is my final answer for my range? I'm looking over here. The range is all values greater than or equal to 0. That's a 10 or 15 second question that I took probably 10 minutes on, but it's important stuff. It's important because many students still don't get it. You might still not get it, but I'm trying to do my best. Okay. Now, I did say there was going to be another method to do this, and there is another method. I'll give you one little tip here. Assuming you're still awake. Here, what are all the x values? What's another way? Well, the function inside the square root, we know it needs to be greater than 0 or greater than or equal to 0. So we say 3 minus x must be greater than or equal to 0 because we're not allowed to have a negative square root. Just solve that for x. So we see 3 must be greater than or equal to x. Or in other words, if we just switch the sides, I'll just put it down here. That means x must be less than or equal to 0. Oops. X must be less than or equal to 3. Sorry about that. Which is the same thing that our graph told us, but it shows it by math. How are we feeling so far? Have I lost you? Is there snoring? Maybe if your microphones were on, I'd hear some sneaky snoring going on. You know, you
No,
shouldn't
it's
be
okay.
thinking at 3:10 in the afternoon.
All good, all good.
All good.
Yes.
Okay, let me give you my cheat sheet. Are you ready for this? Sir, just give me the answer in 5 seconds or less. Fine. You can do this, but I'll give you my quickest answers. First of all, this is for range. This is notes on range. The square root form, which is any root, usually has range y greater than or equal to 0. The 1 over x form usually has range y cannot be 0. So what I mean by this, let me just connect it all. This is my special note for square root form. I can see I have square root form over here. So I'm just going to go ahead and trust that this is true. And in most cases, it will be true. For basic square root functions, it is true. So I'm just trying to give you a shortcut for those that are a little bit confused by this, okay? Give you something to hold on to. You'll notice here, finally, 1 over x form usually has this. Well, this is 1 over x form, all right? I'd like you to try that question, okay? I'd like you to take a minute, 2 minutes, try to tell me what you think the domain and range of this function are. You're allowed to get it wrong. You're just learning this. But think about, first of all, graph the function. Second, what possible values can you have for x? Or more importantly, which ones are not allowed? And 3, give me the range. And I've already told you what the range of this is, okay? Take 2 minutes, see if you can tackle this problem, and we'll come back, okay? Put your answers in the chat if you feel comfortable with that. All right, so I don't take too long. Hopefully, if you're working on this, you're pretty close to the end. Hopefully, if you're not working on this, you're going to at some point. And I already saw in the chat, Abdullah, you gave the 2 correct answers, which is great. I just want to make sure that we're all clear how to get those. So first of all, the first thing you need to know is what does domain mean and what does range mean? Well, D comes before R, so D goes with X. It's the set of X values. That's a squiggly bracket and an X, such that that's a straight down line. X, well, if I look at this graph to the right, you'll notice it shoots up to infinity and then goes back down. In the middle here, we're not actually allowed to have an X value. If you put 0 into this function, it doesn't work. That's because you'd be dividing by 0. You're not allowed to divide by 0. You might know this. It's a real bad thing in math. So X cannot be 0. We're not allowed to make it 0, right? On bottom here, you don't want 7x. Oops. 7x is not allowed to be 0, which means x is not allowed to be 0. So of course, that's what we have to write. For the range, I told you already that this is 1 over x form, which means y is not equal to 0. So we can take that for free. But the reason for that is because the only value that would give 0 is if you divided by 0, and it's not allowed. So I'll just give it to you for free, okay? You can look at the function here on the right, and you can see that there's no value for 0. There's an asymptote. That means that this function never touches 0. It goes close to 0, but never touches. There's no y value of 0, okay? But long story short, you can use my shortcut, and that's enough, okay? As long as you figure that out. So that's pretty much it for these types of domain and range problems. We haven't covered, we didn't do ones of this type, but Tom did that in his video, so you can go back and watch that, similar ideas. But that's pretty much it. And then D, you can try graphing that on your own, okay? I'll just put that as homework. The full solutions will be posted later. We've got one more function I want to cover. Would you like me to do one more example? Would you like me to do this exponential example?
Yes.
Or
Yes.
Yes.
everyone's like, oh God, yes, yes. So don't let them put it for homework. All right, I'll do it. We have the time. Plus, I'm in charge. This is my show. It's not a Netflix show, but at least, it's better than watching paint dry. So let's see here. I'll graph it first, which I said you should do. This is what this looks like. Y equals, hey, this suddenly got really big. That's convenient. Y equals 4 to the power of x. Whew, what a function. Nice. Okay. Me, being the person that I am, I can look at this and I can tell what the domain and range are. Because I know that this function clearly is always going to go to the left. It's going forever and ever and ever and ever and ever that way. And it's going up, but it's not just going up, it's going up and over a little bit. And if we go long enough, it will technically go on forever, okay? On a long enough scale, it's slowly creeping to the right. Do you see this? I could do this all day. It's slowly creeping to the right. You can put in any value there. The reason for that, if you put 4 to the power of a million, you're still going to get a y value out of it. There is no restriction, right? You're allowed to put any x in. It's never going to be a problem, really. So let's go ahead and solve this one. In this case, domain is the set of all x values, the collection of all x values, such that x, what's my restriction on x again? Is there a restriction? Is there any x that's going to break this? My sketch, I can sketch it like this. It looks like this. Is there any restriction? Is there anything x is not allowed to be?
Above 0.
Well, put in 0, 4 to the power of 0. What is it?
It will not touch the 0, I think. Or let's see. Yep.
4 to the power of 0 gives 1. That's okay. I'm just testing numbers.
After the 2 or
It's never going to touch the 0 on the y-axis, I think is maybe what you're thinking about.
after the 2, I think.
It will never touch y equals 0. So we're going to have y greater than or equal to 0. So who's saying after the 2, Juma?
Yeah.
After the 2, we'll just try it yourself. Put x equals, put 2 into this, 4 to the power of 2. Does that work? No, 4 to the power of 2. Does that work? Yeah, of course it does. It's 16. What about 4 to the power of 3? Does that work? Does 4 to the power of 4 work? Does 4 to the power of 5 work? If that's all okay, there's no restriction on x. Nothing's going to break this function. And of course, you can always keep multiplying by 4. So the final answer here, there's no restriction. You're not dividing by 0, and you don't have a negative square root. So it's all real numbers. That means all real numbers. For r here, y. In this case, y will never touch the x-axis. So y has to be greater than, oh, sorry, not equal to. Y has to be greater than 0, not equal to. It'll never touch. And y is, all the rest of the real numbers are okay, as long as it's bigger than 0. You'll notice there are no y values down here. Like there's no y values. There's no function to talk about. Function doesn't exist in that region. No restrictions. Yeah. So Muhammad, exactly. I wanted to avoid talking about asymptotes because it's something that we talk about more in the next chapter. But yeah, 0 is an asymptote, which means the function tries to get there, but it never quite makes it. It's like if you were to try to walk out the door, you know, I walk towards my door, and every time I walk, I had to go half the distance. So the first time I go 10 meters, and then I go 5 meters, and then I go 2.5 meters, and then I go half of that, and half again, and half again. I'm going to eventually get close to the door, but I'm never going to quite make it. I don't know if that helps any of you, but that's basically what an asymptote is. It keeps getting closer, but it never makes it. So unfortunately, exponential functions, y values are never going to make friends with the x-axis. It's kind of a sad situation. You know, you can't always have a happy ending, I guess, even for math functions. Okay, so now we have that out of the way. I'm going to go to our last topic of the day, assuming that everything's okay.
I have something about question A about the log equal x, log x. In Tom's video, they say the domain it's R, but it's not R because the domain it's above -1, I think, to R.
I think I agree with you. I seem to remember that. Let me see.
Because I tried yesterday to put log x and it's not R.
Yeah, all the x values. Yeah, there's an asymptote here. I think log, let me see. I'm just going to check it on my calculator because I haven't done this one in a while. It needs to be greater than or equal to 0. So the answer here, this is a bit of a challenge question, which I put there. If it's a challenge question, it's normally something I would not ask on a test or an assignment, but it's still something that might be nice to try if you're interested in this sort of thing, which some of you are. And so I'll just write the final answer. X actually has to be greater than or equal to 0 if we write it like this.
Yep.
All real numbers. The range, in fact, can be all real numbers.
Okay, that means it will not touch the 0, but it will be.
Okay. Will not touch the 0. You mean the y-axis?
Yeah, I mean the y-axis.
Yeah, it means that you can never, remember the y-axis has a value of x equals 0. You can never get x equals 0 to be the value, which is why, oh, I've made a mistake. Sorry. Right here, it can't touch 0, so it should have greater than 0.
Greater than 0.
Sorry, I didn't. Normally, I like to look at the examples ahead of time. I try to make sure I get it as quick as possible. When I don't, I make mistakes, but I'm just human. So that's
Yeah,
the
but
answer for this.
when we put for y, when we put log negative something, it will not be present because error. That means the y is not r, all real number.
No, it's x values that you're putting in, right? You're not allowed to put in zero negative x values.
Oh, okay. Okay.
It's x values we're talking about. We can still get all the rest. Okay, thanks for that. I never have a problem with those separate questions. It just depends on how much time we have, but we have a little bit of time today, so it's okay. Besides that, this goes for everybody. You can always send me a message too. If there's a specific practice problem that I didn't cover in class, that you want the answer to, or you want it explained a little different way, I don't mind sending a 30-second video to you. It doesn't bother me, as long as I don't have to do 100 of them a day, okay? So let's move on. The last section.
Okay, thanks, Mr.
The last section for what we're going to do today is called piecewise functions. And I'm actually only going to take a piece of this. Okay, piecewise. I'm only going to do a part of this because it's not actually in the course outline, but it is a very important subject to know. So what it means, what piecewise means, is you can have two functions that are stuck together. And depending on the domain, they are one function or the other. Let me show you this. Let me show you the whole picture. For example, in the range, anything between 0 and 4, which is this range. So I'll just actually make it clear here. Anything in this range must be this function. So this function, let me make it clear here. That's the function x minus 2x, okay? In that range, sorry, in that domain, that's the function that exists. As soon as it hits the 4, we kind of throw away that function and put in a new function. And so once it hits anything bigger than 4, we're going to use the function 0, which is literally just a straight line at 0. So everything after, let me try to speed this process up. Anything bigger than 4, it's going to be this line, and I'll just draw it clearly here. It's this line. This is the function f of x equals 0. No matter what x value you put into it, you just get back 0. Okay? I'll do one more thing to try and make it as clear as I can. This section here is x less than or equal to, sorry, x is greater than 0 and less than 4. That's this section. After that, of course, this is your x greater than or equal to 4, all of this. And it goes on forever. So to try and make this as clear as I can, what a piecewise function is, it's two or more functions put together which make a new function. And you can piece them together any way you like. For example, I could have this function and I could have this function, and maybe I only want to take the left part of this and the right part of this. No, that's a terrible example, actually. I'll bring up an example and we'll do it, okay? That's the easiest way to do this stuff. So look, first of all, I'm actually not going to sketch these. You can skip these because I'm not going to ask you a question like it, all right? So for the first time, you can skip something. You can thank me later with test marks.
Thank you, thank you.
I said thank me later. All right, and now in this case, we're going to have these two functions. Now, I'll tell you right away. Graphs would be given on a test. If I was going to give you the graph, if I was going to ask you to do something about graphs, they would be given. But generally, I'll probably just ask you to work on this and then evaluate. But I'm getting ahead of myself. Let me graph this so you see what I'm talking about. I need to remember how to graph piecewise functions now. I think I can remember. Just give me a second. Okay, I think the function is for x less than or equal to 2, It needs to be the function 1 over 2 x plus 4. Will that work? Maybe it's a column. Yeah. Okay. So that's this function. Look, you see at the end here, it goes all the way until 2, and then it just stops. You with me? I'll do this again in a second. So the function, let me call it f of x, is it exists anything less than, sorry, anything between 2 and 5. You, of course, don't need to do this part. I'm just showing you how I do this. 5x plus 10. Okay, now this is getting to the point. This is my function. You see this? This looks crazy. Sorry, 1 second, just 1 second. Everything okay? Sorry, my child is just screaming as if someone just pulled his arms off, and he's fine apparently. I think he just doesn't want to put on pants, which is probably something that a lot of us are struggling with these days. Okay, so let me get to the point again. This is a function made up of 2 different functions. I'll try to make it as clear as I can. This function, this blue function, exists less than 2. So we'll put in this imaginary line here. That function, of course, is the 1 over 2 x plus 4 function. That exists when x is less than 2. Anything greater than 2, that's this guy, and less than 5, so this is our 5 here, is whatever that function looks like. Okay, so the reason this matters is if we want to evaluate the function, if we want to put x values in, we need to know which function to pick, depending on where the domain is. Let me try to make this more concrete. Looky look here. Evaluate the function. I'm going to do the first question. Tom did it, but not everyone watches those, or at least has watched them yet. The function when x is -1. Which function am I going to take? Let me try to number them here. I'll call this function 1, and I'll call this function 2. I'm even putting 2 colors. The value x equals -1, which function are we going to use? The first or the second one?
First one. First one.
It is the first one because -1 is less than 2, so we have to choose that function. So let's do that. We'll choose this function, -1 plus 4. Again, that's our, we're going to use this function. And then we'll get our answer. Half of -1 plus 4, so half of 3, that's 3 over 2. Or 1.5, same thing. That makes sense. I'm going to do another one right away. F equals 2. Now this is a tricky one. Also the first one. Let me put it down. X equals 2 equals 2. Okay, the first function is it exists for anything less than or equal to. So it can be less than or equal to 2. So you're right. Thank you, Paddock. It is exactly the first function. It cannot be both. It has to be one or the other. And so in this case, it's the first one. 1/2 of 2 plus 4. That's 1/2 of 6, which is 3. So our answer here is 3. Third one. Which function? The first one or the second one? When x is 4, which function does it act as? The second one. Yep, second. It's between 2 and 5. 2 is, of course, between, sorry, 4 is between 2 and 5. So let's put that in. It's now 4 squared minus 5 times 4 plus 10. If you're confused, note that I'm, oops, it's a little big, a little bit aggressive. This one is this one. Try not to get confused by the colors. Take time. I try to make the colors logical. What is our answer here? 4 squared, 16 minus 20. 16 minus 20 is -4 plus 10 must be 6. Do I remember correctly or if I worked it out correctly? I computer's about to die. And then the second one, I mean the last one. Can you still hear me? I just had an issue with the microphone.
Yeah.
Yes, we can.
Which function, 1 or 2?
Both of them.
Both.
Yeah. No, the first one.
The first one.
No, the
The
second one.
second one, أبو الشيء.
The second one.
The first one because
First
it's
one?
greater
No,
than
no.
no one. Oh, zero.
No one.
Yeah.
No. With Simon معلش.
The function only goes up to 5 and then it just disappears. It doesn't exist.
Yeah.
It's only between 2 and 5, yeah? It doesn't exist past 5. So this function does not exist. And that's okay. All right, so I'm just glad that some of you are thinking, some of you are like, what's the point? What is this even now? But I want to hope that you're thinking about this. Now let's just quickly check these on this function, all right? And this will actually be, let's see, is this the last thing I want to do today? I might have you do one example, but I'll stop after this. Let me show you what happens here. Let's check our numbers. Let's check the value. Sorry, I've got just a nest of cables here. It's driving me crazy. The function at -1. Why is that a problem? You can find that from more than one place. Okay, I'll just, let's just try this. Function of -1. Wait a second. I won't spend too much. No one stopped me. No one noticed that I put in the wrong function here. How dare you? 1/2, x plus 4. Okay, this is what the function looks like. It's actually much nicer. 1.5, that's our value, yeah? We put x in for -1 and we get back 3/2. And the Desmos is saying it's 1.5, same thing. Let's check the function. When we put a 2 into it, we get a 3. Done. What about if we put 4 in to the second function? Gets back 6, same thing. The last thing I'm going to show you, and I'm not trying to overwhelm you, I just want you to make connections between what we're doing and what it looks like. Let me graph the point, -1 and 3/2. Okay, it exists on the first function. You can see it right there. Let me graph the point 2 and 3. Okay, it exists right there. That's a good thing. It's on the purple function. Let me graph the point 4 and 6. It's right there. It's on the second function. And finally, let me try to graph the point 7. Oh, wait. Doesn't exist. Because 7 is over there somewhere, right here. And if we go up, it just stops. There's no point. There's no point to do it. Get it? There's no point. Why? Why bother? Anyway, I haven't had enough to eat today. Probably like a lot of you. I haven't had anything to eat today, to be honest. So I'm kind of just, I'm losing energy. I'm losing brain power. That's why I'm being silly. Hopefully I'm not driving you crazy. So let me summarize what you need to know for this. When you're given a piecewise function, you need to know which function to choose given on a particular x value. And so with that in mind, I want you to give me the answers for this. And when you do that, once everyone has gotten given a try, or at least, you know, some of you have given it a try, we'll stop there, okay? So see what you can get for that. Give a couple answers in the chat. We'll check it, and then we'll be done for the day. So you can see my answers, or at least what I think it is. Is it negative 4.5? Let me see here. 4 plus 1. No, it's not negative. It should be positive. Okay, I'm just keeping an eye on the time here. These aren't long questions. I want you to at least try them. And if you can get 2 of the points, 3 of the points, you should be okay. Just before we go, I have a couple quick things I want to say. First of all, I just wrote the answers. I'll just quickly note down which function you would use, so you can check it later if you want to. It's 1, this is 2, this is also 2, and then the last one is nothing. It doesn't exist, okay? So that's it for that question. Hopefully you can get those yourself. The last thing I'll say is, well, 2 things I'll say. The assignment was moved to Sunday. I know I said that before, but not all of you might have heard it. And the last thing is the test format. I know I said it was going to be 10 multiple choice, and that was it. I've had a discussion with the team, and what it looks like we're going to do is it's still 10 multiple choice, but they're going to be for short answer questions that are basically 1 step, 2 steps maximum anyway. And so that's it, 10 multiple choice. But there's going to be 4 long answer questions that are marked as normal. And so that is 20 marks for long answer, 10 marks for multiple choice. And I think that's a lot more fair way to test you, okay? And I hope that works for everybody. It certainly works for me, and I think it's a lot more fair, all right?
So the test is gonna be on D2L,
Yeah,
like multiple choice O.
yeah, there will be, I don't know exactly how it'll look yet, but what I would expect is there's going to be a multiple choice section quiz that you'll open the quiz on D2L and do the multiple choice, and then you'll open the Dropbox and get the paper questions.
Also,
so
there's
can,
2 types, 2 parts.
That's the idea, right? Just to keep it simple. Like you have the quiz, multiple choice, and you got your Dropbox, which you do on paper. Send it all back. We'll talk about that a little more later, okay? I don't want to go too late on this. So I'm going to stop the recording here. Thank you, everybody.
can you send